block elements in quite a elaborated manner. 1 second, yes. Hi Royal Sudha, hi being an IITN. Hello, very good evening guys. Quickly go call up your friends and yeah, now am I audible? Now am I audible? Sorry. Can you hear me now? Hi Irfan, hello, very good evening guys. What's up? Yes? Okay, great. Alright, so quickly go call up your friends because today we are going to do magnetic properties and then what else was there? Then we are going to talk about colored compounds and then F block is also left, yes. And there are two very important ones, that is potassium dichromate and potassium permanganate, about which also we are going to learn today. So quickly go call up your friends so that we can start right away right now. But before that, how about let's do a quick recap, yeah? Let's do a quick recap. Do you all remember that in this session we are reading about group D and not group D, D block and F block, isn't it? D block and F block. Good evening Harshit, good evening everybody. Welcome to the class. Let's begin everyone. Are you ready? Write down some la 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 or give me a fire emoji or something. Just let me know that you all are ready. Come on guys, let me see. Now I don't see chats only. No one is interacting. Hello. Yes, Guria is ready. Very nice. Hi Siri Monica. How are you? Hi Neelaranjan. Hello. Okay, amazing. Now finally see one la la la. Yes, finally I see one la la la. Amazing. Thank you so much. Okay, so now let's begin. Yeah. So if you remember, we are talking about the D block and the F block, isn't it? Now the F block is already outside the periodic table because why? If they were inside, then it would look disruptive, right? It won't look like the pretty periodic table that we have, and that is why they are outside, isn't it? Now in D block, we spoke about this 3D series very elaborately. Then we spoke about zinc, cadmium and mercury not being a transition element, right? Why? Because they had what? Why are they not considered transition elements? Anybody? Any idea? Zinc, cadmium and mercury were not considered to be transition metals. Why? Answer? I need the answer in the chat box, guys. Let's see. Need the answer in the chat box. Hi Jayavant. Yeah, very good. ND10, because they have fully filled d orbital, isn't it? And what was the definition? The definition was that they are supposed to have partially filled or half filled, incomplete. Basically it has to be incomplete, that is why. But they have D10. Yes, they have D10. They have fully filled, and that is why they are not considered as transition metal, right? We remember this, everybody. Isn't it? General properties. What are the general properties that we read about? We read about the melting point, and we know that the half filled ones, they have the highest melting point, especially tungsten. Tungsten has the highest melting point, if you remember this, right? And more the unpaired electrons, what happens? Yes, the melting point keeps increasing and then it decreases again. Why? Because the number of unpaired electrons again decreases, right? Do you remember this, everybody? Do you remember this, everyone? Yes, we are done with this. And there are some exceptions also, like manganese and Tc, although they have D5 configuration, but they have low melting points. Why? Because of weak metallic bond. Yes, weak metallic bond. Why Zn plus is not transition element? Bacha, you tell me. You should know this. We are already done with it. Yes, enthalpy of atomization is also something that we already read. Yes, we are done with this. Apart from that, variation in atomic size, that is also done. And now we are going to go for the what? Magnetic properties. Now magnetic properties is actually very easy. It is very easy. The moment you look at the, look at the chart, you can easily understand that, oh, that is why. That is why. Magnetic property is quickly very closely related to what we have studied this in coordination compounds, if you remember. Yes, see it. What is it? Just by looking at the formula, you can tell me. Hello, Optimal Learning with VR. Hello, welcome to the class. Yes, tell me. Just look at the formula and tell me that magnetic properties is very closely related to what, everyone? Remember that Bohr magneton. What was it? What was it? Come on. The moment you answer that, you get it. The moment you answer that, you actually understand the magnetic property. Completely you understand. Hello, Kartika. Hello. Thank you so much. Lakshmi, VBT and all you forget. You just tell me what is it. VBT does not explain magnetism. It is CFT. Tell me, guys. Come on. Arey, Harshit. What is it closely related to? Hello. It is closely related to unpaired electrons. You want to see it? Take a look at it. Okay. Let's take a look at it. Okay. Let's take a look at it. Here you go. See, unpaired electrons 0. Magnetic moment is 0, calculated is 0, observed is also 0. See, unpaired electron 1, it is 1.73. Unpaired electron 2, 2.84. Unpaired electron 3, 3.87. 4, 4.90. 5, 5.92. And you see that manganese has the highest magnetic moment. That means it is paramagnetic. Understand this. Paramagnetic and diamagnetic. Paramagnetic means it is magnetic. Diamagnetic means it's not magnetic, right? Now, paramagnetism, when are you going to see it? You are going to see it when there are more unpaired electrons. Magnetism, right? This whole magnetic scene that comes into the picture, why does it come? It comes because of unpaired electrons. There are no unpaired electrons, no magnetism. Correct? We know about this already. We have studied this in coordination compound. Do you remember it or not? And you can see it. See, it's very nicely seen here. Unpaired electron 0. Calculated magnetism is also 0. Magnetic moment is also 0. Yes. And you can see that 5 is the highest. Obviously, there can only be 5, right? Because d orbital has only 5 empty spaces. So, 5 is the maximum unpaired electron that you can have. After that, it is again going to be 4, 3, 2, 1. Isn't it, everyone? Yes, isn't it? 4, 3, 2, 1. That is what it is going to be, isn't it? Yes, everybody. Why is the first ionization enthalpy of Cr is less than 0? Optimal learning. We will talk about your doubts a little later, but first try to understand this. Are you understanding this, everyone? Are you understanding this? Did you get it? So, this is how the magnetic moment is done. For calculation, you have this formula, which again, we are done. So, in inorganic chemistry, see, there are few things that are very important. One, the chapter coordination compound is very important, and the second, periodic properties. You know this chapter, trust me, everything else gets sorted. Any which way, everything else is sorted. And that is exactly why I did these two chapters in the very beginning, so that everything else looks very closely related to it. Yes, so we have seen this and we know this, right? Now take a look at this. See, titanium 3 plus has 1 unpaired electron. Titanium 2 plus has 2 electrons. Acha, now tell me, if I write Ti4 plus, what will be the magnetic moment of this? Tell me the answer. Ti4 plus, titanium 4 plus, what will be the magnetic moment? What will be the magnetic moment, everyone? Think. Come on. What is it? Hello, guys. Very good. Harshit is the first one who answered. Very good. It will be 0. Why? Because we know that titanium has what? It is 3d2, 4s2. Correct? Now, if it is titanium 4 plus, that means these two gone, this two gone. That means, of course, there are no unpaired electrons. 0. That's it. Yes? 0. That's it. Correct? Okay, now moving on, everybody, let's move on. Now let's understand formation of colored compounds, colored ions. Now in this also there are 2 to 3 things that you have to remember. If you remember that, then everything else is going to be easy. Optimal learning, bacha, can you please focus on what I'm teaching first, and then we will talk about your doubts, okay? Please wait up. Anyway, there is going to be another session where I am going to discuss the most important question, which is tomorrow, okay? So please wait up. Everything is going to get solved. You don't have to worry about it. Right now, please focus on what I'm teaching you, alright? Yeah. Now, see, there are first things first. If there are 0, you see 3d0, 0 electrons. If there are no electrons in the orbital, who is going to jump from lower state or up, this thing, or who is going to show you the colors? Nobody is going to show you the colors. That means obviously it is going to be colorless, yes. Ti4 plus 3d0, colorless, but titanium 3 plus has 1 electron. It has 1 unpaired electron, right? And that unpaired electron can jump. It can jump, right? It can jump. And because it can jump, it shows a beautiful color, which is purple. You can see purple color here. Now, why do you see color? Why do you see color? This is a very lower grade concept that you all have learned. Why are you seeing color? Yes? And what is the color that you are seeing? What is the color that you are seeing? Very good. Why are you seeing purple? Because it is definitely, what is it doing? It is absorbing all the other colors. Yes, it specifically actually absorbs the yellow color. Yes, it specifically absorbs the yellow color, and that's why you get to see the purple. Yes, now here you get to see blue. Why? Because it is definitely absorbing the red color, and that is why you get to see blue, or you get to see green. Again, same thing. It is absorbing the red color. Spectrum. That's true. That's true. That's true. That's true. Absolutely right. Energy is released in visible range, but it is absorbing all the rest of the colors, and whatever is not absorbed, that is what you get to see, isn't it? We all know this, right? So there are some other colors. In fact, this is also there in your NCERT, if I believe, right? This kind of chart is also there in your NCERT. If you just take a look at that chart and if you try to remember few of them, I think it's easy. Okay, I think it's easy. This is understood, everyone. Magnetic moment and formation of colored compounds we have already understood. Catalytic property we have already understood, isn't it? Yes, everyone? Correct? Okay, this is done then. This is done. Rest all the other colors you can do it. See, vanadium 4 plus is blue, vanadium 3 plus is green, vanadium 2 plus is violet, chromium 3 plus violet, manganese 3 plus violet, chromium 2 plus blue, manganese 2 plus pink. Yes, iron 3 plus yellow, iron 2 plus green, cobalt 3 plus, cobalt 2 plus, both of them show blue pink, and nickel 2 plus is green, copper 2 plus is blue, zinc 2 plus is colorless. Why zinc 2 plus is colorless? Why is zinc 2 plus colorless, everyone? Zinc 2 plus is colorless. Why? Why is zinc 2 plus colorless? Anybody? Siri, can you tell me? Optimal learning with VR, can you tell me? Why is zinc 2 plus colorless? Because you can see it is still 3d10. 3d10. What is it? 3d10, 4s2. So 2 electrons gone from s. No. But 10. It is completely filled. Completely filled. All paired. All paired. And you all know that in this. Okay. So let's say that it is a coordination compound, and here the splitting is happening. Here the splitting is happening like this, right? 1, 2, 3, 1, 2. Now let's say here it is filled, here it is filled, here it is filled, here it is filled. Everywhere it is filled, correct? Now tell me, even if this electron wants to jump from here to here, is it possible? Is it possible to have 3 electrons? No, no way. What will they do? They will be like, you know what? Get away. Get lost. They will push it down, isn't it? And that is why it will come back again. So it is not possible to show any color. That's why Zn2 plus will be colorless. Do we understand this? Colored compounds, is it absolutely clear, everyone? Yo or no? You or no? Oh, by the way, some more things that you have to remember, okay? Some more things that you have to remember. Listen to me. If it is 3D0 or 3D10, either vacant or fully filled, no color. You change the ligand, color will change. You change the ligand, color will change, okay? And the third one is, if you let's say that if H2O is the ligand, and if you heat it, then what will happen? The ligand will run away. If the ligand runs away, then again you will have no color. Yes, you heat it, the ligand will run away, right? And that means that you will again have no color. So the moment you heat it, if there is H2O ligand is H2O, it will run away, no color. Yes, so these are the 3 things that you have to remember when you are studying about colored ions. These 3 exceptions, and you are done. You are good to go. Yes, got it, everybody? These 3, is it clear? Will you remember it? Tell me once again. Tell me once again, what are the 3 things that I told you? Fully filled or 0? Fully filled or 0? No color. H2O is the ligand, heat it, it runs away, no color. Change the ligand, what will happen? Color will change. Yes, that's all, okay? Why are you leaving optimal learning? Why? Just because I'm not solving your doubt right now, but I'm teaching, no? Maybe next class you will have doubt related to this. So learn now, so that you don't have doubt related to this at least. Anyway, shall we move on then? Come on, give me some la 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 if we are done and if we are ready to move on. Give me some la la la, everyone, if we are ready to move on. Come on, come on, come on. Yes or no? Yes or no? You know, I'll tell you something very funny, yeah? I'll tell you something very funny. Praveen, Royal, Sudha and everything. Like when I teach this 6 to 8 kids, no? They are like fully talkative. They're constantly talking. They will not stop. They will not stop. You will have to literally beg them, "Bacha, please keep quiet. Let me teach you something." And then you all are there, completely different. You all are like, properly studying and making notes and everything. You have doubt. If I tell you once that, "Bacha, wait, I'll take your doubt in some time," you will understand. So I have to tell you that interact, write down something. And there are those students who will non-stop just blah, 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 blah. They'll keep talking. They'll not stop only. Non-stop they will talk. Exactly, I understand, but it's like I'm teaching the two extreme ends of the spectrum. One that will never stop talking, and one that those are not talking only. You have to tell them, "Bacha, talk no. Tell me something. Interact with me." But yeah, great to see that. Yes, exactly. What is la la la? Harshit, when you're happy, what do? La 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 la. So when you understand something, you're happy, and that's when you do la la la. That's all. So that's what I've tapped. Whenever you understand something, just write down la la la, so that I know that you have understood and I can move on from that. Okay. Chalo now. Moving on. Now let's go to potassium dichromate. Now in these, what are the things that we have to understand? Very easy. Just like how we have how many questions may expect from block elements. From Jaya, have you watched that session? I have taken a session, bacha. Detailed. I have spoken about all this weightage of inorganic chemistry, complete inorganic chemistry weightage I have told you. Would you mind going to that? Because right now on top of my head I can't remember, but if you go and watch that session, I think you'll understand. Completely, from what chapter, how much do you have to expect, how much you have to expect, you will get all of the details, okay? Please watch that, Jaya. In fact, I'll show you if you want. I'll show you which one is the video so that you can watch it, okay? Anyway, now just like any other things, like in the previous chapters also how we have learned, thank you so much, Harshit. We all know that whenever it comes to something like this, some compound like this, what are the three things that we have to learn? First, we have to learn about the preparation, laboratory preparation, industrial preparation, and then we learn about their chemical reaction with acids or bases. So this is exactly what we are going to do. Let's take a look at it. Potassium dichromate. Yes, now potassium dichromate, we know that it is kind of an orange color structure, right? It's a orange color structure. Now take a look at the chromate ion. This is your chromate ion. Yes, CrO4, 1, 2, 3, 4. And this is your dichromate. Yes, so there are two chromate. Yes, there are two chromate, dichromate. Now, everybody, let's take a look at the preparation. How will you prepare potassium dichromate? Okay. Now, this preparation, it has to happen from chromite ore. Ore, do you all know? What is ore? What is mineral? Do you know the difference, everyone? Basically, see, this is the basic of metallurgy. Basics of metallurgy. You have read it in lower grades also, but let me tell you. Ore and mineral. Yes. Now, mineral is basically, it's just mineral from where you can get a metal, you can get out a metal. But the problem with mineral is that when you extract the metal, right, when you extract the metal, it's not profitable for you, neither it is convenient for you, right? It's not profitable, neither it is convenient for you. So that is why you go to ore. Now from ore, when you extract the metal, it is profitable and it is convenient for you. That's the only difference between ore and a mineral. So basically, an ore is also a mineral. But every mineral is not an ore. Get it? Yeah? An ore is also a mineral, but every mineral is not an ore. Now we are going to take chromite ore here. Okay, we take chromite ore here, FeCr2O4. That's your chromite ore. When you take chromite ore and when you treat it with sodium carbonate, or you add sodium carbonate and oxygen, okay, what happens is you get sodium chromate. Okay, what do you get? You get sodium chromate. All right. Now sodium chromate and ferric oxide and carbon dioxide will come out here. Okay. Now this sodium chromate that you have, what do? You add concentrated H2SO4. Okay. What do? You add concentrated sulfuric acid. This is your step 2. Step 1 is you take chromite ore. In the chromite ore, you add sodium carbonate and oxygen. What will you get? You will get sodium chromate and ferric oxide and carbon dioxide. All right. Now from here, you are going to add concentrated sulfuric acid. When you add concentrated sulfuric acid, you get sodium dichromate. And the moment you add KCl here, because see, till now you have sodium here. But what do you need? You need potassium dichromate, no? Till now you have sodium dichromate here, but what do you need? Do you need sodium dichromate? No, you need potassium dichromate, isn't it? What do you need? Our expectation is that we want potassium dichromate. So what are we going to do? We need something that has potassium in it. So potassium chloride, KCl, looks like the perfect thing for us, isn't it? So we are going to treat it with KCl and we will get potassium dichromate, and this Na, what will it do? It will definitely react with chlorine and it will give you salt. That's it. Easy preparation. Easy preparation. So what are the three things that we have done here? 3 steps, 3 things we have done. We have taken chromite ore, added sodium carbonate. Yes, we added sodium carbonate. Then what did we get? We got sodium chromate. We got sodium chromate. To the chromate we added sulfuric acid. After sulfuric acid we saw again that we have sodium dichromate we have. But we need potassium dichromate. So what did we do? We added KCl and we got our potassium dichromate. That's it. Once again everybody, let's say this. Let's say this. Can I have the answers also in the chat box, everybody? Say this with me. We took chromite ore, sodium carbonate was added to it. What did we get? We got sodium chromate. To the sodium chromate, we added sulfuric acid. We got sodium dichromate. But sodium dichromate is not what we are expecting. We are expecting potassium dichromate. So we treated it with KCl and we got our potassium dichromate. Easy? Easy everybody? Yes, this is done. Now, potassium dichromate is actually known for its oxidizing action, my dear student. It is known for its oxidizing action. In acidic medium, you know, it is written as 14H plus. That means it is acidic medium, isn't it? Yes? Yes. So, we are taking acidic medium and what do you get? See, Cr2O7 2 minus. Yes, its action in acidic medium. Take a look at it. Cr3 plus 6Fe, you will get ferric and you will get water out. Okay, you will get water. Can you explain one more time? Sure. Minecraft, let me explain this once again, everybody. Okay, is there anyone else who did not understand this? Anyone else who did not understand this? Let me explain again. Minecraft gamer, we are talking about how to prepare potassium dichromate. Okay. Now the preparation is very easy. Okay, preparation is very easy. What are we taking? We are taking chromite ore. We are taking chromite ore. Okay, this, do you see this? FeCr2O4, this is your chromite ore. Now to the chromite ore, you added sodium carbonate. Yes, sodium carbonate and oxygen. What did you get? You get sodium chromate. Chromite ore, you add sodium carbonate, you got sodium chromate. Now to the sodium chromate, you added some sulfuric acid and then you got sodium dichromate. Now sodium dichromate was not what we were expecting. So we treated it with some potassium chloride, yes, 2KCl, and we got our potassium dichromate. Got it? That's the one that we were talking about. Okay, that's it we have spoken about. Now we are going to talk about oxidizing action in acidic medium. What are we talking about? We are talking about oxidizing action in acidic medium. Alright, let's talk about this, everybody. Okay, how is it oxidizing? How is it oxidizing? How is it oxidizing? Can you find out the oxidation number, everyone? Find out the oxidation number for this and find out the oxidation number for this. You will see. You will see. Hi Lokesh. Okay. When you say solid state, when did I say solid state? Bhagya's world. I don't think I said solid state. What is oxidizing agent? Kartika. Kartika, which class do you belong to, sweetheart? Which class do you belong to? Huh? Which class do you belong to? Do you belong to class 11? Then I expect you to know what is oxidizing agent. Lalitya, very good. Okay. Okay, very good. Kartika, you belong to class 10. Ah, that's why. Chalo, no problem. You wait. This session is not for you right now. Sit and understand what you can understand. Okay. Don't worry about it. Yeah. Lalitya, okay. Plus 6 here. Now, what about this? What about this? Find out for both of them. Find out for both of them and then tell me. And then, actually, you know what? Don't tell me also. You can understand. You can see that here is where the oxidation is taking place. Okay. In case of this also, if you just treat it with iodide, then also you will see that here also it is getting oxidized and you will get iodine here, okay? You will get iodine here. Now let's talk about how does it react with hydrogen peroxide. This is the easiest one. This is the easiest one, my dear student. Cr2O7 2- will react with, again, see, it will again react with hydrogen peroxide and acidic medium. What do you get? You get chromium oxide peroxide, okay? Chromium oxide peroxide, 2CrO5 plus water. This is what you will get. And this, no, this, it has a very weird shape here. Can you see the shape? This shape, you know what is it called? It's called as butterfly structure. It is a butterfly structure where the oxidation number of chromium is +6, my dear students. So this is why you have to know this, okay? You have to know this, all right? Very good, space station, very good. Well done. Okay, got it everybody? Also, the color is deep blue color, beautiful deep blue color, as you can see. Okay, now moving on from here, now let's learn about potassium permanganate, and here we are going to learn about an interesting concept also, okay? Take a look at it. So, potassium permanganate, as we all know, it has this pink color or you know, we can say that slightly purple color, this thing, right? Yes, correct, isn't it? So, now if we learn, we have to learn about preparation, of course, like I said, preparation and then chemical reaction. These are the two things that we learn, and in preparation, we learn about laboratory preparation and industrial preparation. So, now see, in the previous one, in potassium dichromate, what did we take? What ore did we take, everyone? What ore was it that we took? Chromate ore. But here we are going to take pyrolusite ore, okay? What is the ore? Okay, remember everyone, what is the difference? Major difference, take a look at it. For potassium permanganate, we take pyrolusite ore, and for potassium dichromate, we take chromate ore. Yes, do remember it. Okay, do remember it. Now here, step 1, you will take MnO2, manganese dioxide. Okay, manganese dioxide. Manganese dioxide, you are going to add oxygen. Actually, it is, in many books it is written as, you know, in many book it is written as oxygen, but in reality you use it, you know, you usually use KClO3 or what was it? Anyway, I forgot. Anyway, so you add KOH. Okay, this has to be alkaline medium, my dear students. Somebody said acidic medium. No, this is alkaline medium, you know. KOH is alkaline medium, right? So manganese dioxide in alkaline medium and oxygen will give you potassium manganate. What is it giving you? Potassium manganate, okay, which is green in color. Alright, it is green in color. Now this potassium manganate and water will come out, correct? Okay. But do we need potassium manganate? We need potassium permanganate. Yes, IntelliPlace, you can. All of these are common syllabus. You have to study it, whatever exams you are giving, okay? These are common syllabus that you will have to read for everywhere, okay? You can use it, okay? Now, please take a look at it. Please take a look at it, everyone. This is very interesting, very interesting. So, you have potassium manganate, okay? So, let's take the manganate ion here. Now, this manganate ion, do you see that it is in +6 oxidation state? This is in +6 oxidation state. If you don't believe it, calculate it. Calculate the oxidation state here. You know how to calculate oxidation state. I have taught you in coordination compound. Do you remember? Yes? Do you remember, everybody? Great. Now, what do you see here? That this is in +6 oxidation state. Now, see, something very interesting thing is going to happen. From +6, you will see that right here, the oxidation state changes to +7. Also, it gets reduced to +4. One single metal is changing its oxidation state to +7 as well as +4. Do you know what is this kind of reaction called as? This kind of reaction is called as a disproportionation reaction, okay? What happens? The same element gets oxidized as well as reduced in the same reaction. Isn't this interesting, everyone? This is interesting, right? I don't think we have ever seen it somewhere else. Never in our lower grades, definitely, right? What do we see? Manganate ion, yes, when you add it, when you treat it with some acid, what do you get? You are getting +7 oxidation state as well as +4 oxidation state. And this kind of reaction is called as disproportionation reaction. Yes, and now what you're going to do is same step you will follow, and then you will go for commercial preparation. For commercial preparation, same thing. Remember this, we just got no MnO2, this +4 oxidation state. We are going to take this and we are going to see. What are we going to do? We are going to fuse it with potassium hydroxide and oxidize it with air. You will get manganate ion. You're going to get manganate ion. Now after the manganate ion, what will you do? Electrolytic oxidation is what we are going to do in alkaline solution once again, and we will get our permanganate ion. We are going to get our permanganate ion. That's it. Preparation is complete. Now laboratory preparation. This is also very easy, my dear student. The moment you look at it, you can understand that it is very easy. See, what did we do? Mn2 plus, okay, and then we have peroxodisulfate, okay, this S2O8 2 minus, this is your peroxodisulfate, everybody. S2O8 2 minus, this is your peroxodisulfate. Yes, what will you get here? You are getting permanganate and sulfate. Yes, SO4 minus, okay, and you are getting bas hydrogen plus ions. That's it. That's your laboratory preparation. And then you just, what you have to do, you just have to balance it. That's it. All you need to take is manganese 2Mn2 plus, okay, Mn2 plus, and you are going to take peroxodisulfate. You are going to get permanganate. That's it. Easy, no? Laboratory preparation is easy, everybody. Yes, laboratory preparation is easy. Now, for the other preparation, remember the disproportionation reaction. If you remember disproportionation reaction, that's it, okay. Kannan Bali, I would say that, okay, if you, the tricks I have told you already, Harshit, no? I have told you the tricks. See, this is very easy. Peroxodisulfate. Laboratory preparation of potassium permanganate, you have to remember peroxodisulfate. For industrial preparation, what do we remember? Remember disproportionation reaction. For commercial preparation, remember disproportionation reaction. And for laboratory preparation, remember peroxodisulfate. Rest, you just have to balance it. Two things you have to remember. That's it. Isn't it? Understood, Kannan? Two things. Just practice it once. You will be able to understand. Okay? You'll be able to understand. Got it, everybody? Now, let's take a look at chemical reaction. Yes. So, if we take potassium permanganate and if we heat it, what will we get? We will get potassium manganate and we will get manganese dioxide. Obviously, it's getting decomposed. Right? It's breaking down. That's what you will get. Next, what is the chemical oxidizing property? In acidic medium, okay, this is also very important and interesting. Take a look at it. You take 2MnO4, okay, then what do? You'll have to take something electronegative basically, right? E minus, okay. So, iodide, we have taken iodide. Now, iodide will become iodine here, okay. In acidic medium, iodide is forming iodine, okay. Take a look at it. Now, in neutral or faintly alkaline solution, if you take, what will you get? Iodide will become iodate and you are getting OH minus. That's the only difference. Take a look at it, everyone. Alright, let's do the acidic medium once again. See what is happening here. Yes, MnO4 acidic medium. This is your acidic medium, right? This is your acidic medium, H plus ion, so acidic medium. And you are giving iodide. Iodide changes to iodine in acidic medium. Iodide changes to iodine in acidic medium and it produces Mn2 plus and water. But in case of alkaline, faintly alkaline solution, what do you get? Faintly alkaline solution, you get OH minus and iodate. Iodate is what you get. Once again, everybody, in acidic medium, iodide becomes iodine. In faintly alkaline solution, iodide becomes iodate. Clear? Is this clear? These are the only differences. Easy? Easy? These are all you can learn in one day. You can learn it in one day. Correct? Yes? Yes. Okay? Alright. Cricket Hawa, I am teaching you everything, bacha. What are you saying? Anyway, now let's come to F block, and we are about to be done. And the chapter is about to be over because F block does not really have much to study. It's going to be like fat like this. We are going to finish it, okay? F block, just be with me for a little bit more time and we are going to finish it. Trust me, we're going to finish it. Now, F block. So, we all know that F block is anyway outside, right? Outside of the periodic table. And we know that it starts from lanthanum. So, in F block, there are two this thing, right? There are two periods. There is lanthanum and there is lanthanoid and there is actinoids. Yes, isn't it? Lanthanoids and actinoids. So, you see that it starts from lanthanum, that is 57 atomic number to 71. Yes, 57 to 71. Yes, lanthanum to lutetium, that's your lanthanoids. Okay. Now, what's their general electronic configuration? Normally, they are all silvery white metal. Okay. Now, take a look at it, my dear student. Take a look at it. Here is an exception. Here is an exception that you have to remember. Okay. The general electronic configuration for this lanthanoids is xenon, then 4f1 to 14, 5d01 and 6s2. Now, it is written as 1 to 14, right? 1 to 14. But what if I tell you there are two numbers that does not exist? Two numbers that does not exist. Do you know which ones? Do you know which ones? It is 2 and 8 that does not exist. The moment there is F2 or F8, that moment itself D comes in and D is like, you know what, give me one. Give me one. D will take it. D does not allow. D will be like, aha, I'm not allowing you to be F2 or F8. It will not give. The moment F has 2 electrons or 8 electrons, D will be like, oh, give me one, please, 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 give me one, give me one. It will take. Why? Let's see. Let's see here. See, this is what? It will be 4F7, 5D1, 6S2. But it cannot be 4F8, 5D0. 5D will also come into picture, no? 5D at this point, 5D also comes into picture. So, 5D is like, why should I be alone? Why should I be just empty? I also need one electron. It will take one electron. Now, see, in the D block, what did we learn? We learned that from S to D, it jumps, isn't it? From S to D, it jumps for stability reason, right? For stability reason, from S to D, it jumps. But here what happens? From F, it jumps to D. It jumps to D. Are you getting my point? Remember it, in D block, what did we read? We read that from S, it jumps to D because the energy gaps are very small, right? So, the moment S is, at the outside, S is standing like this, but D is like, let me also see what is going on. Hey, have you seen this? How many of you have performed in a stage or so? Have you all performed in a stage? Maybe some of you have performed in a stage. Have you performed in a stage? Come and tell me, guys. Tell me. Have you performed in a stage? If you have ever performed in a stage, then you must have seen that this is your stage, let's say. So, one of your friend is like, they're all performing and everything. But then backstage, there is someone who is waiting for their turn, right? So, what will they do? They'll be like, they do this, isn't it? They do this, right? And then parents and all who are sitting there, they'll be like, oh, no, there is my kid, they're going to come. So, same like that used to happen in D block also. S is the one who is performing there. S is like, taka din, and everything. But D is like, hey, I'm right here. When is my turn? D will also come. So, from S, it jumps to D. But here what happens? From F, it jumps to D. From F, it goes to D. Okay? Alright? Yes, everyone. Vijender, I can't understand so much of Hindi. I'm so sorry. Do you know Kannada? A little bit. I can only fight with the auto walas and I can tell them that 1.5 illa. All of that I can say, but not so much. Now, here are the exceptions. Okay? What are the exceptions? The exception is Ce, cerium, Gd, gadolinium, and you have lutetium. Okay? These three. So, you can say serious God looks. Okay, like Hrithik Roshan, what do we say? Hrithik Roshan, for Hrithik Roshan we keep saying, he's like Greek god and everything. So, we can also say like, seriously God looks, serious good looks. So that is what it is. You can remember it as cerium, good looks, okay. So cerium, gadolinium, lutetium, these are the exceptions. In these three elements, you will see this. You will see that from F it jumps to D, okay. Remember it? Everyone, will you remember it? Now in lanthanoids, what do we expect? We expect that from when it moves from left to right. Why CE? You want to see? Chalo, I'll show you. I have the, take a look at it. See, what happens to cerium? See, it is supposed to be 6s2, 4f2, 4f2, right? 6s2, 4f2. This is what it is supposed to be. But what does it become? It becomes 6s2, 4f1, 5d1. Here is an exception. Then what do you have? You again see it that 6s2, 4f8 it is supposed to be, but it becomes 4f7, 5d1. And for lutetium again you see that 6s2, 4f14. Can it be 4f15? F only has 14 orbitals, right? So F will not be able to take another one. So instead of becoming 4f15, it becomes 5d1. I already told you, no, for 2 and 8, that is an exception any which way. Jaya, noted bacha, I will try and bring it to you, okay? I will try and bring it to you. So do you understand? Serious, good looks. Clear? Alright? Clear? You will again see the same, you will again see this here also. You will see this here also. Here you will see, where is it? I think here also it is there. 7s2, 5. This is an exception. There is no F. This here you will see, okay? Then this here you will see. Here you will see. And there was this here. Here you will see. Rest everything has C. 7s2, 5f6. 7s2, 5f9, 7s2, 5f7, 7s2, 5f10, 7s2, 5f11, 7s2, 5f12. Okay. Oh, here also Lawrencium also you will see. Lawrencium also you will see 6d. See, D gets introduced. Okay, D gets introduced. All right, D gets introduced. Everybody. Okay. Now coming back to lanthanoid contraction. Now. When we were reading about periodic properties, do you remember we said that from left to right when you move, we want to see an increase in the atomic size, right? We want to see an increase in the atomic size, correct? Because noble gases are really big, correct? Noble gases are really big, but we don't get to see it here. We don't get to see it here. And why are they so infamous? Because of F orbital, my dear student. Yes, because of F orbital, and we all know that F has the worst shielding effect. Now, you must have, okay, let me give you another example of shielding effect. Do you all remember what is shielding effect, everyone? Harshit, find out the atomic number and then find out the atomic configuration, you will see it. Find out the atomic number and find out the atomic configuration, you will see why it is not there, okay? Go ahead. Okay, anyway, now moving on, yes. What was I talking about? I forgot. What was I telling you? I wanted to give you another example. Yes. Yeah. Lokesh, bacha, pehle, please focus here. Focus here what I am telling you. Wait. Lanthanoid contraction is more important. Okay. So what I was telling you, see again I forgot. I shouldn't look at the chats only. What was I telling you? Oh yeah, shielding effect. Yes. So remember that example I gave you about one accident that is happening and you are going by the bus and you see that if there are too many people then you don't get to see the accident, but if there are less people around then you get to see it, right? But sometimes have you seen it that shielding effect is also seen in your houses? Like my brother, right? Like normally of course I do love my brother, but he's younger to me, right? So there are times when I have to save him, right? And there are times when he has to save me. But that guy, my brother, is such a mischievous kid. You know what he used to do? When we were both in school, he used to go and tell mom about everything that I do, you know. And because of him, the moment I used to enter, I used to get this. Properly I used to get this. But I have saved him. There were many a times when he was getting beaten up and I had to like, Mummy, no, don't beat him. I had to save him. So at that time when I had to save him, the shielding effect was great. He did not get beaten up, right? He did not get beaten up. But when it came to when it came to his responsibility to save me, what did he do? He was like, Mom, you know what, I saw her today. I think she took some money from home and she was eating in the canteen. She was not eating the tiffin you sent, Mama. He did that. So what happened? The moment I entered, properly I got beaten up. Right? Why? Because that guy did not shielded me. What do you do in school? I told you. So I must have taken the tiffin, but I had probably saved. Oh, okay, but I never stole from my parents, right? I never stole from my dad's pocket or anything. But you know, he used to give me for the bus fare, right? Yes, thank you, Aryan. Thank you so much. Thank you. So my father used to give me like, you know, 5 rupees or 10 rupees for the bus fare and everything. So I used to save from there, and I must have eaten it in canteen, and this fellow used to go and tell mom that, Mama, she was eating from the canteen. She did not eat the tiffin. She must have shared it with all her friends. So he used to do that. But anyway, so you understand shielding effect, right? What happened? This happened. I got beaten up like this, isn't it? Now the same thing happens in lanthanoid contraction. We also know that F orbital has the worst shielding effect, right? F orbital has the worst shielding effect because F looks like this, isn't it? It looks like this. 1, 2, 3, 4, 5, 6, 7, 8, something like this. Now you see that there is gap here. There is gap here, there is gap here, there is gap here. Everywhere there is gap, right? Everywhere there is gap. So this nucleus, it can easily see the electron here, easily see the electron here, 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 and it can pull them. And that is why what happens? It, this is what happens, okay? It goes like this. Yes, the inertia, that example we have already given, space station, yes. So do we understand that due to the shielding effect of 4f electrons, such a poor shielder they are, that the size decreases, which is called as lanthanoid contraction. So how will we remember lanthanoid contraction? Because of poor shielding effect of 4f electrons. Okay, that's all we have to learn. Got it? Now let's take a look at the oxidation state. Okay, oxidation state, everybody take a look at it. Now in this case, the most common oxidation state is of course +3, +3, +3. Yes, +3 is the most common oxidation state. Yes, everybody. But there are also other oxidation state, as you can see, like this cerium, PR, TB, di. I can't remember all of their names also. I only forget. Okay, they have +4. These ones have +2, and these ones have +2 and +4. So that's it. +3. +2, +4, that's it. That's it is the oxidation state, okay? That's it is the oxidation state. Got it, everybody? Yes, clear? Now here are all the names. You have, oh, this is what it was. Cerium, praseodymium, you can remember it as prasad, okay? Then you have, what was it? CEPR, terbium was there, correct? And what else was there? dy is dysprosium, that's it. These are the ones that also has +4 oxidation state, okay? All right, chalo. Now moving on to chemical reactions of lanthanoids. Let's take a look at it. Harshit, what happened, bacha? What happened? What are we talking about? I told you, no? You find out. I've given you assignment. I have given you assignment, right, Harshit? I've told you. You find out the atomic number and then take a look at and find out the electronic configuration. You will see. That's it. I've given you the assignment. You do that on your own, okay? Now, chemical reactions of lanthanoids, okay? Okay, take a look at it. What do? They burn and they form Ln2O3, okay? All right. When you heat them with sulfur, they form Ln2S3. When you heat them with nitrogen, very easy, they form LNN, okay? All right. Now, when you heat them with carbon, they form LnC2. You make them react with water, what will they form? They will form LnOH3 plus H2. If you make them react with halogens, they will form LnX3, okay? All right. Hi Shamul. And then with acids, they will form H2, okay? All right, that's it. Now we go to actinoids, and that's the last leg of this chapter, okay? After that, next tomorrow what time? Tomorrow I think at 5 p.m. Tomorrow at 5 p.m. we are going to do the important questions, bacha log. So all of these questions that you are asking about electrode potential, and you are asking, ma'am, why thorium, clear thorium, and what happens to effective nuclear charge, all of this we are going to take a look at it tomorrow, because we are going to discuss some of the important questions, and those exceptions we will talk about it there. Is that okay? Will you all be there? 5 p.m. or 6 p.m. I've forgotten, but I'm guessing it's 5 p.m. Yes, I'm guessing it's 5 p.m. everybody. Okay, I'm guessing it is 5 p.m. everyone. Will you be there, everybody? Please be there. Don't forget to be there, everyone, because tomorrow we're going to gets over at Singham. Ko baat nahi, no problem. I'm gonna expect from you that you will come back and watch the session. Okay, you can't be there. Why? 5 p.m. your school gets over, is it? Lokesh, you tell me, no bacha, effective nuclear charge will increase with the number of protons, right? Yeah? Isn't it? Effective nuclear charge increases with the number of protons. Yes. Number of protons increases, nuclear charge increases. What is effective nuclear charge? Effective nuclear charge is basically the total amount of charge that is experienced by an electron after deducting the shielding effect. Isn't it, bacha? Is that not? That's what it is. So you tell me, no? Then what are you asking me from that time? What are you asking me from that time? Chalo, let's move on. Let's take a look at actinoids. So this starts from 89 to 103. Okay, 89 to 103. 103 is lawrencium, and this is your actinium. Now, many people think that lawrencium is the last element. Is it the last element? Which one is the last element in periodic table, everybody? Which one is the last element in periodic table? I want to drink some water, but I don't see any water bottle here. Do I see? Found some. Found some. Guys, please answer everyone, no? I will see what can be done, okay? I will see what can be done. I'll see what can be done. Yes. We are. Sangvi, I am. Very good, very good, Harini. It's OG. It is OG. Very good. Two minutes. Yes, Harshit, I have to provide PDF. You know, the problem is, normally I take this thing, no? I take classes from home, and it becomes very easy because everything gets saved on your laptop. So, fatak say I can send it, right? But here what happens is also the classes happens from different studio. So, I have not been able to get enough time to collate everything and then send it. But I'm thinking of sending all of them on the Telegram group. So, I'm hoping that you all will join the Telegram group so that you can all get your notes, okay? So that you can all get your notes, okay? Chalo, now moving on to actinoids. Shall we move on, everyone? Let's move on. All the doubts and everything will be clear. Don't worry about it. Yes, Shemiyul, got it. You are from Bangladesh. Got it. Hi, hello. Very nice to meet you. Chalo. Now it starts from actinium and it ends at lawrencium. Now most of them are radioactive, especially uranium. Uranium is radioactive. We all know this. Now here also the general electronic configuration is 5F1 to 14 and 6D01. 6D can be 0 or it can be 1. Okay. Now here what is the exception? Let's take a look at it. What is the exception? The exception is curium. What happens to curium? What do we see? We see that instead of 0, it's not 5F8, 6D0, 7S2, but instead it is 5F7, 6D1 and 7S2. This is what it is, okay? 6D0 to 1. Shemiyul, where was the last time that you understood, Shemul? 6D0 to 1, because that is what is allowed, okay? 6D can be 0 or it can be 1. That is what is allowed, okay? Now, here also you see actinoid contraction just like lanthanoid contraction, because again the 5F has poor shielding effect, right? 5F, due to poor shielding effect of 5F electrons, it goes pitchik, isn't it? Now you know what? One more thing is that the actinoid contraction is even bigger than lanthanoid contraction. The actinoid contraction is even bigger than lanthanoid contraction. Yes, you will see that the actinoids, they go even more, they go even like this, they go like this even more. Now imagine I have asked my brother, like, bhai, please don't tell mama, I'm going out, I'm going out with my friends. But what does my brother do? The moment he enters, is like, mama, your daughter has gone out with her friends and she is going to come home late night. And he is adding some more masala in that. Now what will happen? I'll get beaten up a little more. I'll get scolded a little more. What was this? This was even worse. Worse shielding, right? Isn't it? Not only did he tell on me, he added also masala on it. Yes, that's the kind of scenario for actinoids now. Okay, that's the kind of scenario for actinoids. Yes, so they go even more pitchik like this. Okay, so actinoid contraction are bigger than lanthanoid contraction because 5F shielding is even poorer than 4F shielding. 5F is like, they are all chill. They're like, what, do whatever you want. I don't care about shielding and all anymore. You see the electron, great, pull it. What do I care? That's what they do. So it is even lesser than 4F shielding effect. Got it? Now in actinoids also, of course, you get to see variable oxidation state, right? You get to see variable oxidation state here. And the same way, like in D block we have read, in the middle you will see that the oxidation states are more. Like here you have 3, 4, 5, 6, 7, 3, 4, 5, 6, 7 for NP and PU. But rest all of them had 3, 4, 5, 6, 3, 4, 5, 6, 3, 4, 3, 4, 3, 4. Here also you get to see that the most common oxidation state is 3. What is it? Most common oxidation state is 3. Why do they have variable oxidation state? Because again, very less energy gap, my dear student, very less energy gap. Not only is the outermost orbital right outside, but the ones that are inside, they cannot keep calm. Remember, just like that stage performance. Yes, your friends are probably performing like tak dhin dha 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 and everything. But you, who is next in the line for performing, what are you doing? You are now like, shh, the song is about to end, the song is about to end, the song is about to end. What are you doing? You are almost on the stage, right? You are almost on the stage, correct? So this is what happens. This is what happens. Okay, and with this note, everybody, we are done with the chapter. Tomorrow we have a session to take care of all the important question of DNF block, and I'm expecting you all to be there. Will you all be there? Hi Bala, hello, welcome to the class, but you are quite a little late because we are about to say bye now. Okay, alright, how to join Telegram group? Is it not there? Just search for Vedantu Enlite, no? Just search for Vedantu Enlite. I think you'll find it. Royal Sudha, I will talk to the channel manager, and I'll find out what time is free. If it is free, I'll definitely take it. If not, then I expect you all to please watch it later, okay? Please watch it later. Last election can make screening effect. Hari, what are you telling about? Screening effect is basically what the inner electrons are trying to do for the outer electron. Bacha? It's not the last electron. The last electron faces the screening effect that is put by the other electrons. Got it? Alright. Either it is 5 p.m. or 6 p.m. Actually, you know what? Let's check it out. Let me check it out right away. Just a minute. Let me check it here. Let me check it out here. 1 minute. Where is it? And I will find it right here. Enlite. I think the session is already created. Hi, it's at 5 p.m. Yeah, it is scheduled at 5 p.m. because most expected questions at 6 p.m. is done by at 6 p.m. is taken by Shimon sir, 7 p.m. is taken by Shreyas sir. So there is no time only. Either I'll have to do it at 8 p.m. or I'll have to do it at 5 p.m. only. So I think let's do it at 5 p.m. only. I expect you all to watch it later. Will you all be watch it later? Harshit, right now I'm taking every session in one shot so that even if later when your exams are banging on the door, you can't say that ma'am did not complete the syllabus. But I promise you that right now I'm doing one shot, because in this channel nobody has ever done inorganic chemistry. So what I want is to complete your syllabus for inorganic once and then come back and do everything elaborately. So we will definitely come back, we will touch each and every topic, and we will do detailed elaborate study. Okay, we will do detailed elaborate study, but right now we are trying to complete the one shot, and I'm still giving you enough, I'm still giving you, enough amount of enough amount of information, but I expect you to come back for the detailed study also. And now that you all know most of the things, later on when you come back and you try to understand, you're like, oh ma'am, you already told this, right? So it'll be very easy for you. Lalitya, please at 8 p.m. But the thing is, Saturday I want to get done a little bit early, so that maybe I can just go out and have a nice dinner, I can just go out and have a nice dinner. Otherwise, we only get one Sunday off, and that Sunday goes in a blink. Like the moment you start washing clothes, the Sunday is gone. Right? And you don't get to do anything. So can I please take it at 5 p.m. But you all can watch it, right? You all can watch it, okay? Please do watch it, don't worry. And please do tell your friends also. I will announce it in Telegram group, okay? Alright? Yeah. Chalo, with this note everybody, bye bye. I hope that you all enjoyed the 1 hour class. Yes, and whatever is your doubt, will you all please write it down so that I can actually put that in the slides and you also have a note of it. You also make a note of it. Harshit, you had asked me doubt. Lokesh, you had asked me doubt. Whoever had asked me doubt, write it down in the comment section so that I can put it in this thing, okay? Which is the best chemistry guide. You can follow Avasthi. You can also follow, what is this? Claydon. But it becomes a little too high level. Mostly the teachers study that and then they teach. Like everybody has Claydon. I also have Claydon. Yeah, Claydon is something that all the teachers follow. But if you want to have a little easy, I think I would ask you to go for. You want very easy, then you can go for Nimai Tiwari. You can go for Nimai Tiwari also. That's also a very, very, very easy this thing. Okay. So either go for Avasthi or go for Nimai Tiwari. Very easy book you will find, okay? Alright, with this note everybody, thank you so much. If you enjoyed the session, don't forget to like it, and don't forget to tell your friends also, okay? Lots of love and bye-bye. Royal Sudha, HC Verma is for physics. Chalo, see ya guys, see ya. NCERT is enough if you're sitting for NEET only, okay? NCERT is enough if you're sitting for NEET. Okay, but if you want to little more study, if you want to practice, then go for N Avasthi. In fact, I was also planning to take care of some N Avasthi questions, like how Wasim sir has taken. I'll also take care of N Avasthi questions maybe, okay, later on. Right now we will finish everything so that inorganic chemistry, that 34% of marks from chemistry is in our pocket, okay? That I want. For JEE, NCERT is not enough. For JEE, NCERT, Tattva questions and some PYQs. That's enough. These 3 things is enough. NCERT, Tattva questions from Vedantu, and what do you call it? PYQs. These 3 you do. Thank you, Bala. Thank you so much. Thank you, Pranay. Thank you so much. EMCET, that I have to find out. I think that Wasim sir has already done, no? EMCET. That's why I'm not doing. EMCET is already done by Wasim sir. Okay? Chalo. Yes, all the chapters doubt will be cleared. Lots of love guys. I'll see you. Bye bye. Have a nice weekend. Don't forget to study also. Okay.